Hello, Algebra 2, and welcome to the last video of the year, maybe even forever. All right, so hopefully you guys were successful in doing the 5.3 investigation. So this should be very short notes just to kind of solidify what you were supposed to get out of the exploration. So we have the parent function of the square root, f of x equals square root of x. If you forget what it looks like, remember you can always plot points. So if I plug in 0, square root of 0, because this is your square root of 0 is 0. Now what I chose for the x were exact values so that when you take the square root, you get a nice number as your output. So when we go to graph that, you go over 1, up 1, label your axes, over 1, 2, 3, 4, up 2, because the square root of 4 is 2, and then over 9, up 3. So no matter where your graph translates to, this is the pattern and the slope that you should always have in your graph. Over 1, up 1, over 4, up 2, over 9, if you have space, up 3, okay? If you're doing the negative version here, it's basically the same thing, but you're going to go over 1, down 1, over 4, 1, 2, 3, 4, down 2, over 9, down 3. And then it's the bottom half of a sideways parabola is what we have. So you have the top branch and you have the bottom branch. Now we're going to go into doing all the transformations. So when you did the exploration, remember this is a good resource page for your notes because chapter 1 was also all about transformations. We did it with absolute value functions, we did it with parabolas, we did it with lines. Now you are doing it with your square root function. Anything inside the parenthesis is a horizontal transformation. In this case, it's a translation horizontal. Remember, anything inside or horizontal works the opposite. So x minus 2 is actually going to move you in the positive direction 2 units to the right. X plus 3 moves you 3 units in the negative direction or to the left. It's like setting what's underneath the radical equal to 0. That number, whether it's positive or negative, tells you what direction to go. On the other hand, if it is a vertical translation, it is outside the square root, outside the function, it acts exactly as it reads. So plus 7 moves you up 7, minus 1 moves you down 1. And then you would still have the same slope and sort of over 1, up 1, over 4, up 2 pattern. If it's a reflection, so inside is going to be horizontal. A horizontal reflection is going to be in the y-axis. So you're replacing every x with a negative x. Outside is vertical. So this one was horizontal, which is why it's over the y-axis, and this one is a vertical reflection. Then horizontal shrink and stretch, guess what? You don't have to worry about it. I'm not going to ask you anything for those. The vertical, however, we are going to be looking at vertical stretches. So what happens is you're going to multiply your output, which is the y value, by whatever that a value is. So this 4 is going to stretch you by a factor of 4. Now, the way you can also look at this, we did a little table here. Here's your x, here's your square root of x, here's a times square root of x. So for instance, if I put in my 0, 1, 4, 9, this gave us 0, 1, 2, 3 as an output. Well, if there was an a in front of that, it would be a times 0, or a times 1, a times 2, a times 3. That tells you how far up to go as you're graphing your points. All right, so let's try a few of these. The key to making these really easy is to be able to find the vertex. If you can find your vertex, then defining the domain and range is super easy. And the way you find the vertex is you look at the radical and you see what would make underneath the radical equal to 0. So in this case, x minus 3 equals 0 would be a positive 3. So you're horizontally moving forward to 3, and then the plus 4. So it's the opposite of whatever's under the radical, but exactly what's outside the radical. So that's our vertex. So we come over here to 3, 1, 2, 3, label our axis, 3, 4 is where we're going to start. And then we do the same routine that we did on the other one, over 1, up 1, over 1, 2, 3, 4, up 2, and then that's as far as we're going to fit on here. So we draw our graph. Now when we go to express the domain and the range, one nice little thing to do, you don't have to do it this way, but if I put a little sort of box, half a box around my vertex, going in the direction that the graph is going in, so we can see the domain in the x value. Remember, domain goes with x, range goes with y, d comes before r, x comes before y. So the x's are going to be greater than or equal to the x coordinate of the vertex. And my range, in this case, because the arrow is going up, the graph is the top branch of your sideways parabola, is greater than whatever the y value of your vertex is. Those numbers on the domain and range always correlate to your vertex 100% of the time. The only thing that might switch is sometimes your range will be y is less than or equal to when there's a negative in front of your graph, in front of your equation. Okay, let's look at this next one. So looking underneath the radical is just an x. What would make x 0 is a 0. What's outside is plus 4, so that will be a 4. So my vertex is at 0, 4. 0, 1, 2, 3, 4. And now this one has a negative 2 for its dilation. So what we're going to do is we're going to go over 1, but instead of down 1, we're going to go down by 2. You multiply that distance by 2. I'm going to go over 4, 1, 2, 3, 4, and instead of going down 2, I'm going to go down 2 times 2. So 1, 2, 3, 4. And if I go over 9, instead of going down 3, I'm going to go down 6. So 3, 4, 5, 6. And that would be your graph with a good showing of the dilation. Okay, so it's negative, so it goes, it's the bottom branch. So our domain, x is, well, again, here if I do my little box thing, notice now x is still going forward. So x is going to be greater than or equal to 0. The y's now, however, because it's going down, it's the bottom half, goes less than or equal to the y value of the vertex. All right, let's do one more, a couple more, two more. So our vertex here is going to be a negative 3 and 0 because there's nothing on the outside. And so I'm going to go back to a negative 3, 0. And this is positive in front, but times 2. So I go over 1. Instead of up 1, I'm going to go up 2. Over 4, 1, 2, 3, 4. And I'm going to go up, instead of 2, I'm going to go up 4. And then 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6. So we double that. So that gives us that dilation of 2. And there's your graph. And to state the domain and the range, so notice that x is greater than or equal to a negative 3. Y is going to be greater than or equal to 0. Okay, so you can see it's really about, if you can find the vertex, everything else is pretty much falls into place. So this last one, my vertex is going to be a positive 1, because that's what would make underneath the radical 0. And on the outside we have a positive 4. So I'm going to go over to 1, 1, 2, 3, 4. That's where my vertex will be. And this one does have a negative out in front. So I'm going to go over 1, down 1. over 2, 3, over 4, down 2, the square root of 4, and then over 9 and down 3. And sometimes if you can only fit on at least the 3 dots, that's fine. So there's our graph. And again, you don't have to do this little box. I'm just trying to visually show you how to get the domain and the range. Domain is going to be x greater than or equal to 1, the x coordinate of your vertex. And the range is going to be less than or equal to the y coordinate of your vertex. And that is it. So good luck, and good luck on your finals.